Are we ready? First off, look, I find a lot of times students make this way more complicated than it has to be. You got to read this, okay? They're telling you that the temperature of some potato is measured by H. So if you plug a number into H, you get the temperature of the potato at that time. They have given us the derivative. You notice there's an H in that derivative? Yeah. So if we had to solve for H, we'd have to separate those variables, okay? And I know that's what we've been doing in class, and that's what it looks like you should do here, but they're not going to ask you to do that at all, actually. Okay? But they gave us a derivative, and they gave us a point. They told us at time 0, that potato is a smoldering hot 91 degrees Celsius. Okay? So look, before we even get into any questions, here's the information they've given us. At 0, the temperature is 91 degrees. That's what we know. Yes? Okay? And if I want to know the slope anywhere, I got to plug in to the derivative. But please pay attention, very common mistake is that kids plug in the wrong variable. That's an H in there, which is the temperature, not the time. Okay? Okay. So yeah, if I wanted to know the slope at 0, because that might be helpful eventually, I could plug 91 into there. Okay? And when you plug in 91, what do you get? Negative 16. Yeah, 64/4 is negative 16. That means that if you were to zoom in on this curve right here, it would have a slope of negative 16. Does that make sense? Okay. So that's all the information we know. Let's see what they ask us. Oh, what luck. The first question is find the tangent line to H. Does it make sense? I just kind of drew it right there. Okay, at 0. Remember we said the tangent line needs 3 pieces? A y value, an x value, and a slope. Well, they gave me the x value is 0. Please don't let the t equals 3 confuse you, okay? Read this part by part. Find the tangent line to H at 0. Okay? It's going to be y minus, what's the y value at 0? 91, right? Okay? It's the heat. It's the temperature of that potato. Has to equal something, the slope, which we're going to pretend we don't know yet, has to equal, you can put a t or an x in here. I'll put in a t since that's our independent variable, right? Minus 0. That's what all of our tangent lines look like. Only thing we're missing is the slope. So I need to know what's the slope of H when t is 0. Very common thing kids do is put a 0 in here for H and find it, right? Don't do that. You want to put in 91. And we already did that over here, and it was negative 16. So, okay? That is the tangent line. Here's what that says. If that's all we know about this potato thing, okay, what's that negative 16 represent in terms of this problem? Not just the slope. If you're, I know the question was not asking this, but if they ever ask, explain in context what it means. You cannot just say a generic thing like it's the slope. You got to put it in context. What's it mean? Then maybe very true. It's the rate the temperature's decreasing, right? So okay, let's put that in more a little clearer. You're right. It's absolutely correct. How about the potato's temperature is decreasing by 16 degrees Celsius per minute at 0. It's not going to keep doing that. The rate is changing, okay? But that's what's happening exactly at 0. Then they're asking me, use that tangent line to approximate the temperature at 3. Okay? Does it make sense that all we want to do is plug a 3 in here? All right. But can I explain to you again what we're actually doing when we do that? We are assuming, when you use a tangent line, we're assuming that the slope is constant. We're assuming that every minute goes by, this temperature is going to drop by 16 degrees, right? So after 1 minute, the temperature should be 91, take away 16. That happens to be 75, right? After 2 minutes, our predicted temperature is going to be 75, take away 16. Now this is not going to be to scale, but forgive me. That's going to be 59. And after a third minute, it's going to go down 16 more. And we're going to say that is 43 degrees. So based on the information we have currently, we believe the temperature will be somewhere around 43 degrees. Okay? And that's exactly what you get when you plug 3 into here. Does that make sense? I'll do it up here. But if you plug in 3 into this thing, you get negative 16 times 3. That's negative 48. You get negative 48 plus 91. And it happens to be 43 degrees Celsius. Put your units on there. Make sense? And does it make sense why that's happening? We're just moving that slope the entire time. Okay? Remember we said a tangent line looks like a function, but it only looks like that function around the point where we found the tangent line, right? So using the tangent line to say approximate the temperature at like 0.1 minutes, that makes sense. Using it to find the temperature at 3 minutes, not a great plan. This is going to be pretty far off because we're pretty far away from 0. Okay? We'll tackle that problem next year, how we do better with that. But anyway, everybody read? We're good. Okay. Then it says use the second derivative to tell if it's underestimate or overestimate because we just used our tangent line to make a prediction. Okay? So if it's a prediction, we want to know if it's over or under so we can better gauge like how our answer like reflects what's actually happening. Okay? Anyway, the second derivative, I'm hoping you guys did this, is negative 1/4 times the derivative of h minus 27. Well, the derivative of h with respect to t is dh over dt. It's not a 1, it's a dh over dt. And you don't want to leave dh over dt in there. Okay? Plug back in what dh dt is. It's negative 1/4 times negative 1/4 times h minus 27. And you can leave it like that in a free response question if you want. But I'm going to simplify it over here. The second derivative with respect to time is positive 1/16 h minus 27. Okay? All right. What do we need to know if our tangent line is an over or underestimate? What do we look at? Concavity, right? That's why they asked us to find the second derivative as well. So, concavity comes from the second derivative. That's a square there. And we know, what do you notice in the problem? They tell you something a little weird. Greater than 27 for all time. Okay? So what does that mean? The second derivative is going to be always. It's always positive, which means our graph is always concave up. And if you don't remember the rule for that, draw a concave up curve and draw a tangent line on it and see if it's above or below. It's going to be below. It's an underestimate. Okay? So now instead of saying that our temperature should be somewhere around 43, we can say a little bit better that our temperature is above 43. Okay? That's not super helpful, but whatever. Okay? And then you would write that. So how do they word this? Underestimate or overestimate, determine whether your answer, okay. So you'd write something like my answer is an underestimate. You don't have to get into all the fanciness behind it. You got to talk about concavity, and they actually don't even ask you to explain in this situation. So I think you can just say that, honestly, and get full credit. But just so we get some practice, I'm going to write this out. It's an underestimate because d squared h over dt squared is less than 0. True? And you should say where. Where is it less than 0? Oh, greater than 0. What? Greater than 0? Okay. On what interval do we really care about in this particular question? From where to where? From 0 to 3. Does that make sense? So h is concave up. So you should say not just the second derivative is positive, you should say the graph is concave up. And that's why it's an underestimate. Yes?
Well, the problem always be known that like t is greater than like 27.
You mean h greater than 27? Yeah. Not necessarily, but so then they'd probably ask a little closer to 0. Okay, so if you don't know that, definitely just say that, like find it at 0 and say it's concave up, so it's an overestimate. Like that, okay? Or underestimate. All right? Also, guys, look, they try to make these questions realistic here, right? Or they do make them realistic, I guess. Why might the temperature of this potato always be above 27 degrees? Room temperature. That's what's happening. That's how heat works, right? The temperature is decreasing down to 27. That's what's going to happen. Huh? 91 is pretty hot. Yeah, it's close to boiling. All right? But if you had a potato in boiling water and you took it out, it's going to be close to boiling temperature, right? I mean, it doesn't mean the potato is going to boil. Right? I don't know. I don't know what temperature a potato boils at. You guys okay? Do you notice we haven't really done all that much calculus really here? The first question was no calculus at all. You just had to know what the derivative meant. And the second question, you just had to derive h and get dh dt basically. What's up?
For a, why did you say y equals negative 49?
Oh, it should be 48. Man, this video is ruined. Oh well. Okay. Yeah, we'll add in like a little window that pops up. Okay, that'll be good. Okay. And then for C, which I think is a little unusual, they give you like a whole new equation, and they basically ask you to solve for G, basically, okay? And the only way we solve differential equations is by separating and integrating, okay? All right. And I'm going to go back again real quick. Did anybody start trying to find h? Did anybody start separating that and integrating it? All right. I think you really want to watch being in like auto mode where you just see something you're used to seeing and start doing what you think you're supposed to. Make sure you're reading what they're asking you to do. Okay, I asked that because the last two or the other two classes I have, like several people in both of them were starting to separate and integrate that. It didn't make any sense to do that. It's a waste of time. Okay? Not you smart kids in this class though. They put all the smart kids in this class.
Yeah.
All the ugly kids. Okay. All right. Okay. You can have both, Mark. Look at me, man. Yeah. Future generations will see it. That's our first step. Is that okay? We're going to want to integrate this thing.
Yes.
Integrate. Integrate. That's -1 times dt. Okay? We okay with that? The integral of the right-hand side just in is just -t plus c. Okay? Technically on this side, this is your reasoning. I'm hoping some of y'all can do this in your head. But what we're really going to do is think about it like that, because it's just down the denominator. It's just power rule here. And remember we said you should usually do a U-Substitution if there's an inside function, but there's one small time you don't have to do it. What's the derivative of the inside thing? Just 1. If the derivative is 1, then you can treat it like it's one big variable. Okay? Now, you can do a U-Sub, it doesn't hurt. I'm just not going to do it. Okay? If you integrate that, you're going to get that thing, g minus 27 to the positive 1/3 times 3. You okay with that? We got to find c. They're telling me when t is 0, g is 91. Okay? So when you plug that in, you get 91 minus 27 to the 1/3 is c. And that means 3 times 64 to the 1/3 is c. And it turns out that's 12. 64 to the 1/3 is 4. That means a cubed root of 64 again. Okay? So, c is 12, which means our equation is really not c. Come on now. So what are we going to do first here? We got to get g by itself. So technically, we're done all the calculus at this point, right? We're done. But when they say find expression for g of t, they mean they want g as a function. They want g all by itself. Sometimes in multiple choice, they don't do that. Sometimes they leave their answer with x and y's or whatever on the same side. Generally, on these questions, they want you to isolate the dependent variable. So we're going to, first thing, divide 3. And then, not cubed root, cube it. Right? Yeah. Get rid of the 3 by dividing by 3. Raise it to the 3rd power. And then we're going to add 27 and sit back and think, man, oh man, am I smart. I'm doing differential equations in high school. Look at me. Okay? All right.